Hello everybody. I'm so sorry we're not in class because I'd really like to make slime with you guys and oobleck, some of my favorite stuff. I got this thinking putty from my 8-year-old in the other room and it's really useful. These things are all made out of something called a polymer, and polymers are all over our lives. Plastics are made out of polymers. Polymers are made out of something called a covalent molecule with covalent bonds, and that's what today is all about. And so the objective is this: nonmetals bond with each other by sharing electrons to form covalent bonds. These bonds can be shown using Lewis dot structures. And so if you remember before, all these things in pink are metals. Blue is nonmetal, and so we were working with ionic bonds where metals bond with nonmetals. So now we're just doing nonmetals with nonmetals. And so I wish we could use the molecule kits to help us learn these, but we're going to do the best we can. We'll use the internet. We can make this happen. So there's going to be some notes. So jot this down. Essential questions. What is a covalent bond, and how is it different than an ionic bond? And what's a polymer? And so we're going to be digesting those right now. And so again, ionic bond is metal loses electrons, loses valence electrons, so the shell below is full. Nonmetal gains valence electrons to fill the shell. Remember the octet rule, duet rule? And once they do that, they've got a charge, and then they attract and make an ionic bond. Okay? Covalent bonds are, on the other hand, let's just break that word down. Co means share, cooperate, coexist, coordinate. Co means share, and valent sounds a lot like valence to me, valence electrons. So sharing valence electrons. And the atoms will share valence electrons to fill their shells. So they get the octet rule by sharing electrons. And so here are some examples. Water, hydrogen gas, and methane gas. And so here's my water molecule. I built this using our molecule kit, which I wanted you guys to have, but oh well. And so I just built this like this. And so we've got two H's, H2O, and each one of these plastic things connecting the atoms represents a pair of electrons, shared electrons. So we're going to do, this is the formula, H2O. Structural formula is like that. And so I just wrote down H, that line represents this pair of electrons, O, pair of electrons, H. In a minute, we're going to do the Lewis dot structure, which is the best part. Here's hydrogen gas, just H2, hydrogen, hydrogen, pair of electrons, H2, so H in a line, H. And my last example we're going to do is methane gas, which is CH4. And so this is a good one because you can really see it's three-dimensional. All of these molecules and atoms are three-dimensional. And on the computer screen, they look like they're two-dimensional. But so just recognize that CH4, it still works. See, each one of these lines is my pair of electrons, but you just want to remember that it's a three-dimensional thing. Okay, and so now we're going to work with something called the Lewis dot structures. Who came up with this idea? Lewis. And all it is we're going to show the valence electrons that an atom has with a dot. And so if you recall, we're going to do it for hydrogen here. Hydrogen's here, it's got, and you should have something like this in your notes. Hydrogen has, everything in this column of alkali metals has got one valence electron, including hydrogen. And carbon over here is in the four valence electrons column. And so if we go back to our notes, for my examples, hydrogen has one valence electron, there's H, it gets one dot. And you can put the dot on top or over here, I put it there. Carbon has four valence electrons, so I wrote it like that, dot, dot, dot. Easy. You just got to be able to figure out how many valence electrons they have, which is also easy if you got a periodic table. A couple do's and don'ts. So here's my example for chlorine. Chlorine is over here. It's got 7 valence electrons. And you can do those dots a few different ways, but what I like to see you do, here's what you want to do. Picture a box going around the atom. And so we're going to do the electrons in pairs. So 1, 2, 3, 4, 5, 6, 7. Or it could go 1, 2, 3, 4, 5, 6, 7. There's different ways you can do it. Here's what I don't want you to do. These are not planets orbiting a sun, right? So the next step of this is going to require us to have those dots be really neat. Here it is for carbon. You can go 2, 2, or you can go 1, 2, 3, 4. But again, picture like a box going around the atoms, okay? And so now we're going to come in and take a look. This is the same page you had here, had before, but now I filled in some stuff for you. But so here, back to our hydrogen example. Here's my 2 hydrogen atoms, and of course this is a model. But just notice how they both feel like they've got 2 valence electrons. They're each sharing the pair, so they're both satisfied with the duet rule. So let's do that one first. Here's how I'm going to show it. So each hydrogen has got 1 valence electron, right? I'm going to look at that, and now I want to draw it in a way that shows they've got 2 valence electrons. So I'm simply going to move them around like that, and so each one of those feels like it has got 2 valence electrons. Okay? Check out water. Oxygen's got 6 valence electrons, hydrogen's got 1. And so we just got to, kind of like look at it. We know oxygen wants 8 valence electrons. Hydrogen is happy with 2. And so look at how we did this here. We just brought in hydrogen down here, so it shares an electron, and that hydrogen comes in here. And so oxygen feels like it has 8 valence electrons. Really, it only has 6, but hydrogen is sharing their valence electrons too. Hydrogen only has 1, but it feels like it has 2. And so there's our pair of shared electrons there. Then here's our last example for right now. And these are all single paired shares. CH4, there's carbon, dot, dot, dot. Carbon wants 8 valence electrons, and so we need to bring in our hydrogens with 1 dot, and you just have to move that dot to where it fits. And so each of the 4 hydrogens brings in their 1 dot. So now carbon feels like it has a full shell of valence electrons. It's stable now, and hydrogen feels like it's got a full shell as well. Okay, so last thing on this is, and actually there's going to be a worksheet that goes with this, and I'm going to show you how to do the worksheet in another video. So come back for that. But lastly, just to round it out, some of these chains of covalent molecules can get to be thousands and thousands of atoms long. I call them spaghetti molecules, and that is what is a polymer. That's why you can do this kind of thing. And it can be very useful, and it can be an environmental problem too. And so you can see some of these polymers are crisscrossing here, and they cross bond, and they make all different kinds of things. The key thing is though, and they're all carbon, because carbon, just notice how carbon wants to bond on all sides, and it just makes these long chains that are called polymers. And so more on that to follow. Okay, thanks everybody. Stay tuned for the next video, because there is some more work I want you to do with this.